Hello everyone. We will start today's session shortly. Till some more participants join in. Could you quickly confirm if I'm audible? You can type a yes in the chat box. Thank you so much for confirming. Just couple more minutes and we'll start today's session. Good evening, everyone, and welcome to today's insightful and hands-on webinar, which is Deep Learning Blueprint: How Modern AI Really Thinks. We are excited to welcome you to this in-depth and insightful session on one of the most powerful forces shaping today's AI revolution, which is deep learning. Over the past decade, deep learning has transformed how machines see and how they listen, understand language, and make decisions. So, from recommendation systems and autonomous vehicles to medical imaging and generative AI, deep neural networks are at the core of modern intelligence systems. Yet, for many, how these systems actually think remains a black box, right? So, to guide us through this essential topic, we are honored to welcome our expert speaker, Mr. Rushikesh Meharwade. Rushikesh is the founder of Vidvatta and currently serves as Vice President of Data Science at Motilal Oswal as well, with over a decade of experience spanning data science, performance testing, application monitoring, NLP, which is natural language processing, and corporate training. He has worked with leading organizations such as Capgemini and Renault. He's a passionate educator and mentor for top edtech platforms. And as said, Rishikesh is widely recognized for his expertise in machine learning, natural language processing, Python, and AI problem solving. And please remember, this session is just the beginning. If you are looking to deepen your expertise in AI and machine learning, we invite you to explore our AI and ML programs, which is designed to help you stay competitive and future ready in this AI driven world. So, without further ado, let's get started. Over to you, Rishikesh.
Perfect. Thanks a lot, Lakshana, for sharing about the details. Hi, everyone. Good afternoon to all people from India. Good afternoon, and others based on the time. So, my name is Rushikesh Meharwade, and I'll be the host for you all today on this interesting session on learning deep learning, like understanding about the deep learning, which is the core concept which has driven the whole AI ecosystem. So just before we get started, I need some quick confirmation from you all that are you able to hear me loud and clear? Just please put it over the message if you can hear me. Awesome. Great, great, everyone. Thanks for your response. Happy to see that. So, just to add a brief around myself, I have around 13 plus years of experience in the IT industry. And out of that initial 5, 6 years, I worked into performance testing, different testing related aspects. Then we were working with lot of data around the 2015 to 17, which was a era in data science and the big data learning. So we were doing a lot of large scale data processing, and I was looking for some programs around the AI at that time. So great learning was one of our options around 2017, 16. There were very few players in the market which were actually giving us hands-on experience in terms of great learning. It has been there from that time. We had a hybrid classroom sessions from Mumbai, which was for 1 year. That program at that point was called as a BABI, which is Business Analytics and Business Intelligence. Now, that course actually gave me a good leverage in terms of transitioning into different further roles where I moved from lead data science to manager of data science to vice president of data science. And I'm running my own startup right now where the whole goal is to help people upskill and also doing a lot of consulting around the AI. So that's what I have been doing. So without further ado, let's get started. Before again we get started, can someone tell me like what is deep learning over the chat? Like what do you think is deep learning? And nothing is right and wrong. Be open in terms of asking questions or even putting your feedback. There is no right, there is no wrong. It's all about learning. We are here to learn. So, and again, over this 1 year journey, one more thing I would like to add is keep asking your questions as you get it. I may not be able to immediately answer it, but in between, I will be stopping to see the chats and answer. But don't keep your questions with yourself. Just let it run loose on the chat window. Okay. Perfect. So, can someone tell me what is deep learning as for you? Anything? What do you think of this? So, come on. I'm waiting for some responses before we get started. Okay, that's great. Manjunatha says trained information encapsulated in DNA. Okay, that's a nice way to put in. Deep learning, in-depth understanding. Okay, that's great there. There, Suresh, subset of machine learning. Okay, great, great. Suresh, good. So, yes. So all of you are giving a lot of pointers around what is deep learning, and all of those are right. So deep learning, let's just get started, is all about learning the data in a lot more deeper way. See, we as a humans, like try to think, we don't much think of our intelligence, like how complex things we can do. We don't much give attention to it. Like even if when I'm looking into a screen, or talking or listening, there are so much of data that I'm right now consuming and trying to provide a information. So a lot of things is happening. So if you think of a data, there's so much data that is coming into me, and there's so much data that is going out from me. So there's a lot of depth to the information. Like even there is a conversation, for example, we are not talking about great learning or the deep learning as a topics, but you all know in the back of your mind as a memory that yes, there is this topic going on. So lot of hidden information we as a humans are processing and trying to cater to it, but we don't give much focus. But giving this kind of intelligence to the machine is not that easy. So machine learning as a field was there from the start, which all used to be how do we train the system from the data, rather than we creating our own rules by hand, saying, let's just take an example of credit scoring. If you think of credit scoring, that okay, whether we should give a loan to some person or not, we may have to take data like age, CIBIL, or salary, geography, the previous loans, all those information, and use that historic information to build a model which can understand that okay, this person was a good in terms of giving a loan, and this person was not good in fulfilling the loan. So all that learning, these models do, and then try to create a predictable model. So in future, you give it any new data, it learns. So that was machine learning. pure focused on the structured data. But humans used even now works a lot on the unstructured data. It could be text, it could be audio, it could be vision, images, videos. Like we usually interact with all the system to a good extent. So the existing machine learning was not good in this. So scientists came up with the idea that okay, can we mimic the human intelligence? Okay, we all have this biological neural networks in our brain, and there are like billions of cells, like neurons, present in our brain, and those neurons are connected to millions of neurons. It's such a complex system that we have. Scientists thought, okay, can we replicate this kind of phenomena where these neurons are connected and they are trying to do some processing of information, and then this processing of the information should result in something interesting. So that's where deep learning was born. Why we call it deep learning is it tries to break down the problem statement into much more granular aspect. Just to give you an example, let's take this example of a car. Now, as a humans, we look at a car in a one single pictorial way. But again, we are doing a lot of pattern mining. We are doing a pattern mining. Okay, there is a wheel, there is a door, there is a shape, there is a window. Lot of different aspects we try to take in when we make a decision that okay, this is a car. In the same way, deep learning also tries to break down the problem. At a very high level, you can think of the first layer to be all pixels. Okay, where it's all just the whole pixel as an image is coming. Second layer tries to transform those pixels to a one more advanced layer, like the edges. So the next layer learns edges. Again, one more layer would learn from edges to more better components like wheels or windows, all those things. And again, next layer something more. So every layer tries to break down the problem and learn some more advanced concepts. That's why we call this a deep learning because it learns the data in a lot more depth. So that is the core goal here. So let's move ahead. Now, deep learning has use cases in lot of different aspects or domains. It could be cybersecurity, data science, marketing, finance, computer vision, decision making, LLMs, autonomous systems, sales, healthcare, finance. I just can name like n number of fields, and it may not even stop for a good time. The like applications are everywhere. Every single domain is being impacted with respect to the whole AI, or even with respect to the uh, current new age AI, which is all about the LLMs. Again, LLMs are nothing but a more complex versions of deep learning systems. Now, as we discussed, the whole goal with respect to the neural networks is there is an input layer. This input layer is nothing but all the inputs are going to be fed to this. Then there is a hidden layer, which is a pattern mining system. All of this are mathematical calculations. Okay. In machines, every data needs to be first transformed to some form of numbers. And then through those numbers, some maths happens. And from the math, we get some output. These maths are nothing but the patterns which are learned in the whole system. So these hidden layers are nothing but like every single node here, okay, is learning some different aspect of the data. This is your input. You can imagine from the car example, everything is a pixel. If I go down to that credit card example, every single node is going to take in individual features like the age of a person, the income of a person, the salary of a person, sorry, the civil score of a person, the locality, the gender, all those things will come as an input here. And these nodes are going to learn some different patterns with respect to all this data. Now these we call as the hidden layers because these are hidden as they try to learn some hidden patterns from this data which are not visible to the common eye. Like we as a humans are doing a lot of pattern mining on a continuous basis. We don't feel that, but there's so much is going on as a human. So similarly, here they also trying to break down the problem into different patterns. For example, one of a hidden node may say that okay, if Sybil score is greater than this, it will try to give more focus to Sybil. This other node may create a combination of age and Sybil. This other node may try to learn a pattern around age and salary. The other node may learn some pattern around the geography the previous loans. So like this, every node is pointing to every single layer and trying to learn some different type of rules from every single all of this data. So every hidden node here is learning one type of like different type of pattern from that one single data. Now when we go to one more hidden layer, you can imagine now this becomes the input, like all these patterns which are learned, and this next layer tries to transform the patterns from all these different already created patterns. It tries to learn even more patterns. It's like a next level of complex patterns. It tries to learn from that. Like this, based on the complexity of problem, we can include lot more layers. Now, in terms of LLMs and all, those are like very huge model because they try to capture a lot of different patterns. But based on the problem statement, we may have a different type of neural network. If you're building from the scratch, based on the data, based on the complexity, uh, based on what kind of expectations we have in terms of final output, we may create a different architectures. Okay, these are architectures. We may say I need 10 hidden layers. I may need different hidden layers. Like one start with 10, others start with 20, others start with 30, things like that. So we can have a different architecture. The whole goal of this architecture is to learn the patterns. One thing is I'm giving an example saying that this is learning this kind of a pattern. But it doesn't have to be everything is human understandable. A lot of these things are system is trying to learn the pattern by its own. So just to give you an example, some systems which were created like there's this algorithm which was created using the deep learning based systems called as a AlphaGo. Okay, even Deep Blue. Deep Blue is an example of chess automation where this was used to defeat the top players in the chess. Go was one more complex game which was a lot more difficult than chess, and there is an AlphaGo model created to defeat the top players in Go. Now, one thing happened is when people started to learn this models, what they learned is it was able to come up with new set of patterns which were not known to any top players earlier. I'm just giving an example saying the systems may learn some patterns which we may already not know. So they do this pattern mining from all the data that we provide, and from that pattern mining, it crunches different type of patterns, and then it uses that to make a future prediction. That's a core goal that we have here. If we talk about a high level deep learning and machine learning differences, the whole uh, goal here is with respect to machine learning, these are more statistical algorithms to learn the hidden patterns and relationships in the data. So this was like very early systems which worked on some smaller data and used to give us a good results, even with the larger data, but which is more structured. Machine learning, in any type of problem statements, you always have a rule that, okay, always start with the basic things and then you go toward the advanced. If something can be solved with the basic, you should stay with the basic and then you go to advanced. So machine learning to some level works much faster and much more easier level. So for problem statements which are simple, structured, statistical in nature, we go with the machine learning based systems. Whereas deep learning based systems are slightly complex and they work on a complex problem statement which are not structured, which are slightly unstructured, like the complexity with respect to language, vision, and all of this, can work with the smaller data sets. Like machine learning can get started with the smaller data set, even if you have like 100, 200, 300 rows, you can still quickly build some patterns with some type of models within machine learning. But with deep learning, if you're starting from the scratch and going with 100, 200, it will not learn anything. It requires thousands of examples to learn. It requires thousands of data set to learn from that. So 100, 200 will not be useful in deep learning. Whereas machine learning, you can still get something quickly bought up with machine learning with smaller data, but this will not work at all. Better suited for simple tasks, as I said, better suited for more complex tasks, NLP computer vision. Now, why we say NLP computer vision to be complex problem statements is, again, as I discussed, NLP is very tricky. One word may have a lot of different meanings. The overall sentence may have a lot of different complexities with respect to the understanding, definition, uh, in those aspects. Like some languages follows a different grammars, other languages follow a different grammar. On top of it, the relationship between the words could go very different. That's the challenges with NLP. With respect to computer vision, it's a pixel-based image that you have. Now, the objects are more spatial. There is no sequence of pixels that you can directly pass, but it requires a spatial understanding. That okay, if there is a dog face, you can't just give a sequential pixels. You need a pixels to be in the 2D grid. And this model has to learn this 2D grid pixels. So that all becomes unstructured in nature. And then takes less time to train the model. These are like, as I said, very quick, much faster. Can just build you a quick model in a lot more faster day. Like if you have a good data set pipeline ready, building of models may require just 2 to 3 days. A lot of automation tools are available right now. But if you understand the whole crux of how this model works, you can build things much faster nowadays. And on top of it, deep learning requires a good time in terms of identifying how many layers are required, how many nodes are required, how do we fine tune that, how do we check the accuracy, performance, monitoring. A lot of different aspects comes into the picture when you are working with the deep learning based systems. Models are built using relevant features manually extracted from the detected objects. The whole thing with respect to machine learning is you require a lot of effort in terms of creating a data. See, this is all called as a data science. It's all a subset of data science. Everything is around the data. The whole aspect is we are considering the data is good and we are moving with all these algorithms which can learn the patterns from the data. If data itself is not good, we can't do anything. So first thing, data plays an important role. So if it's structured in nature, then out of that data, there could be a lot of noisy information. With machine learning, we have to handpick the features which are more relevant. For example, as I told you, like if with the credit score, like credit rating we are giving to a person, we have to like in a database there could be a lot of different aspects that okay who is the manager who took it, what was the location, what was the time, like when this form was filled, what is the parent's name, what is the child name, so nominations. You will have a lot of different information, but what is relevant to the given problem statement, that you have to manually analyze, find out, and then give that curated list of features for the model to identify the pattern. If you give it a noise, the model will also take a lot of time and may not give very accurate results. So in machine learning, we have to put some effort in terms of identifying what are the important features. Identifying the relationship between the features and what we want to achieve will be done by the model. But at a human level, some involvement is required to identify the top features. But with deep learning, we can still go ahead with giving everything and it will be able to learn the patterns. We usually don't do that. We usually still focus on bringing all the relevant factors because that speeds up all the process. But deep learning can still go from that unstructured data with noisy data and still learn something good out of it. Less complex and easier to interpret the results. One of our main challenges with the machine learning is the model interpretability or understanding how this model is working. There are black box models and there are white box models. White box means you can actually understand what kind of patterns it has learned. And in other cases, there are also models where you will not be able to understand what kind of patterns it is trying to learn. So machine learning is good in terms of understanding the different patterns, but deep learning, it's slightly tricky to understand what it has actually learned. You can only understand that it is able to do a good prediction, but what are the patterns it has learned? Is it in the car example, has it identified the edges? Has it identified the wheel to be an important element or a shape to be important element? All those things are slightly tricky directly. There are a lot of indirect ways to still understand those. Then you can run on a CPU and requires a less computing power, whereas deep learning requires a lot more power and also GPUs. Now, just one quick question. Does anyone know here why GPUs are important in deep learning? Can someone put it over the chat? Like, what do you think? Why GPUs are important? Okay, I'll wait for you guys to put it over the chat. Like GPUs, like you must have all heard about Nvidia is doing, Nvidia stocks are just going. I lost it, like I'm not put money into that, but Nvidia stock is just going big and big. Recently, Google also came up with its own set of GPUs, which is TPUs, They already had it, but with the new model Gemini 3.0, they trained it in their own uh, new set of chips called as a TPU, and Google is also going good in terms of stock price right now. But GPUs, TPUs, all those are like similar family. Which is why is it required? Like from the gaming, the GPUs are more used, even used for gaming. So from the gaming, why are we using this for deep learning? So one thing is deep learning is not like playing the games. It's very different. But one of the use cases, the games, and another is the deep learning. So why are we going with that? So Siddharth, like you have given a very good full form of it. So yes, it's a graphics processing unit, right? Computing capability. So Suresh, like what do you mean by computing capability? What kind of computing capability GPU gives as compared to CPU? Like CPU is also compute. Uh, because it works with complex data, so it does large compute. Okay. So large compute is fine. See, but CPU is also giving you a compute. So why are we not going with CPU, but we are always talking about GPUs? Like you all must have heard about this kind of conversations about GPUs everywhere. Okay, so let me give you the brief is, see, GPUs are traditionally used for the games because the games are nothing but a matrix of pixels. Okay, so GPUs are very good for processing matrices. So your screen is nothing but a pixels angle, and GPUs have a lot of small cores. CPUs have a lesser cores, but those lesser cores are more optimized to do some sequential processing. Some sequential, a majority of sequential, and to some level parallel. But their whole goal is to do things in a sequential. But GPUs, on the hand, like have thousands of small cores that does a quick computation. So when we want to transform a screen from one look to another look, lot of matrix transformation happens. The matrix multiplication and all is done to do the transformation in the screen. So for traditionally gaming, GPUs were used. Now, deep learning is also nothing but a math, and there's a lot of matrices are used internally to do computations. And to transform those matrices in a much more faster way, GPUs are very useful because they have a complete different architecture. They have a lot of small processors as compared to CPU. CPUs have a limited processors, but the CPUs are much more better in terms of sequential processing. But GPUs runs a parallel processing in a quick way. That's when the systems are much more powerful. And there is a lot of need for GPUs that is going on right now. Okay, I hope it helps you understand at a high level. What does it mean? If you come down to the set of applications which are there are again a lot of different applications which are there with respect to deep learning. One thing is a computer vision. Now, in computer vision, again, there are a lot of different use cases. A pure traditional use case, which is there from a long time, is the image classification. Okay, so let's say you have a CCTV in your shop, and within the shop, like whoever is coming, you want to recognize whether it's a male or female, whether it's a kid or adult. You want to do a classification of individual characters. So you pick up one by one characters or people, and then you send them to a transformation classification model. Classification actually tells you it's an adult, it's a kid, it's a male, it's a female. So we try to classify. Again, there are a lot of different classifications. Like let's say you have got a image, you want to identify what all objects are present in the image. In the object, there is a human, there is a helicopter, there is a horse, there is the elephant. So this model does classify in terms of classes. Traditionally, these have been highly used. Even today, there are a lot of classification models which are used. These are quick to build with the data, lot more useful, lot more faster as compared to other use cases. So classification is a quick example that works out very well for identifying the classes with respect to the images. Second is the object detection. The way, the one example that I told you, you have a CCTV scan and there are a lot of different objects. There are people, there could be some even different objects. Let's say you are pointing outside or you have a lot of cars. So you want to actually pinpoint those areas. And okay, this is where the object is. So that is called as a object detection, where you draw a square bounding box around that object so that you can pick up that object and use it for some other processing. Some simple examples are like head count. Okay, or foot count. So you say that how many people came in 1 hour within a shop, how many unique people came in. So unique people could be you first identify the individual characters, and then through the classification you understand who are the people similar faces, and you reduce the duplicates, and then at the end say that okay, this many people, unique people who have visited the store in the last 1 hour. So those kind of auto counting can be done. You can also identify like with image classification for a given image, you can identify whether that person is attentive or he's a thief, he's a normal person. I'm just giving example with respect to the shop, but similarly, there are a lot of different use cases which are there with respect to the image recognition. Then image segmentation is identifying that exact object with the contours. For example, if I have to just get this person, not anything else. So the bounding boxes is object detection, more of bounding boxes. Segmentation is you exactly identify that this is how the curve looks like. Okay, I hope you're able to see my cursor. So it says that, okay, this is how this person looks like. So that's a segmentation. Again, segmentation has a lot of use cases that you want to exactly fetch that segment and do a lot of operations on top of it. Identifying in medical use cases exact cancer, pneumonia, or any kind of object stuck. So there's a lot of different use cases with that. Then comes the NLP. So with NLP, there are again lot of different use cases. Some of these use cases, one is like automatic text generation that everyone knows about nowadays. NLP, within NLP, we have this generative models. The whole goal of these generative models is to generate images. Okay, so generative is all about generating token by token as output, which are again deep learning based complex models. Okay, just give me a second. Okay, sorry for stopping in between. Okay, so now one is the automatic text generation, which is all about the generative models. Do you all know the full form of GPT? Okay, can someone tell me the full form of GPT over the chat, please? Okay, so that would be right. Perfect. Kiran, you have mentioned it right. So it's not even transformation to some level. So it's a yes, right, Karthik, Chetan, you guys have mentioned it's right. So what we have as a generative, so it's called as a generative pre-trained transformer. So these models are generative in nature. Anything that does a generation are called as a generative AI. That's why we have this Gen AI as a new era which has come up from the last 3, 4 years. So Gen AI is all about generating things, generating text, generating images, generating videos, generating audios, like everything we can generate nowadays with this model. Like there's a 3D generation is available also on top of it. So GPT is generative pre-trained transformer, and transformers are a set of models which have actually made a lot of impact on the industry. Okay, so the transformers are a type of deep learning based models which made it possible to learn a large context data, and also a humongous amount of data can be encoded as part of our information in these models. So that's where like generative pre-trained transformer plays a very important role. All this Gemini, Mixtral, Llama, all these are generative models. Then we have a language translation. So language translation was still has been good from lot of years. Lot of work has been done in the language translation. Even with LLM, we can do a pretty good translation. But even before that, transformers, the language translation has been a very important use case across the different domains. Sentiment analysis, identifying whether the given text talks about positive, negative, or any kind of emotions. This kind of a strategy is very useful in social media marketing or feedback analysis in that scenarios where we want to actually identify whether the given text talks about something good or bad, whether the user is happy, sad, what kind of things the user is talking about. So if you're trying to do a brand analysis, so you have a brand over social media, you want to see what people are talking about. So you will try to get all that comments and try to do a sentiment analysis. You will get a picture around what this, what like all the people are telling about. You can do emotional analysis. So a lot of these things can be done through sentiment analysis, which is all about textual data. And from the text, you want to identify the core emotions. Okay, it could be sadness, it could be anger, it could be anything. It's all about identifying the emotions so that you can take a right decision. Okay, just an example, if all people are suddenly saying over the online that login page is failing. Now, everyone may come up with the different words for this. Login page is not working, login page is failing, login page has gone down. But you don't want to maintain all the keywords, but rather you just want to identify any specific page is being mentioned and what is the sentiment. So if you say login as a page has suddenly negative going, so you quickly know that there's an issue in the application. So nowadays you keep seeing some websites getting down on an occasional basis. So a lot of this kind of thing also help these companies to quickly identify that is there any impact because people suddenly put it over the social media, like all the people who use quickly do complaints over social media or give feedbacks over social media. So social media plays a very important role. Not just that, um, managers' feedback, like the employees' feedback can be tracked out. So there are just n number of use cases. Even with the market, okay, even with the market, you want to understand if there is a stock and there is a positive thing going on or there's a negative thing going on. Speech recognition, actually identifying what kind of words are being spoken and then trying to use those. So these are like some broad level of use cases for NLP and computer vision. So there's a one more category which is called as a reinforcement learning. The reinforcement learning plays a very important role with respect to the environmental data. Environmental data means we allow the systems to learn from the environment. Just to give you a simple example, if any mobile game, let me just ask you a question. Like when you play Candy Crush for the first time, it gives you some instructions. Okay, I hope everyone has played Candy Crush to some level. So if you're playing it in every game, there are new type of levels that comes up. You don't know how to solve. So what you do? Like there are a lot of times a situation where you have got a situation like a scenario which you are not able to solve. And then this is related to any game. So when you're stuck, what would you do with these games? How do you solve it? So this is a general question to everyone. So how do you solve when you are stuck with any game? So what's your approach to go again with any game when you are stuck? And now we are specifically just taking an example of Candy Crush. Yeah, I'm just waiting for some responses. Keep playing. Good, Vamsi. Try the stage again. Perfect. Great. So those are very valid statements. So what we as a humans do is we keep trying. We do some actions. From that action, if things are good, we get a positive reinforcement. And if the things are not good, we get a negative reinforcement. Which when we say negative, it's not still bad. It's still good to understand that this is something not working. I have to try out something different next time. So this time I did this mistake, but let me correct it next time, and then we try to again learn. And this is how humans actually grow in terms of their experience. Every experience is nothing but a learning from the past in terms of positive and negative. So this is also reinforcement learning, which talks about we create a environment where there is an agent. Agent is nothing but any type of player That player has got an environment, which this game could be a complete environment where you are keeping a player, and then the goal of this game is to reinforce this agent with each action. If in the Candy Crush you are doing some actions, if it goes good, then you will get a positive points. If it goes bad, you will get a negative points. So what this reinforcement learning does is it keeps capturing all the positives and it starts negating the negatives. So that's how it tries to continuously learn. There are a lot of use cases with respect to uh, the electrical cars, the autonomous cars, not the electrical, but the autonomous cars, the game playing, even the LLM models use reinforcement learning to enhance the overall behavior, to make this model behave in a right way. When I say behavior, good positive behavior, like it always greets you in a right way. And when you end, it also does a good greeting. So all those are coming through the reinforcement learning. So there is a separate field of reinforcement learning which is applied. So with reinforcement learning, you can do game playing. Models have achieved a superhuman performance in different type of game. This is something I was talking some time back. Robotics used to train robots for tasks including object manipulation, navigation, automation. So the reinforcement learning is used to help this model understand that if you're trying to pick up an object, if you're not able to pick up, you will get a negative score. So it will keep trying all the possible options. Okay, should I do this? Should I do this? Should I do this? Should I only do this? Should I do this? It will keep trying every possible action. And then when it does this, it will understand that, okay, this is a positive reinforcement. I got it. So that's a core goal. We also, as humans, learn. When we don't know things, we keep trying, trying, trying. And then after a lot of tries, we get to know, okay, these are all the mistakes I did. And now this is the right thing to do. So that's a core goal here, control system. So that's a use case with respect to the reinforcement learning. Coming to the advantages with deep learning, there's a lot of possibility with respect to the higher accuracy. We never imagined that a world like today would exist where AI systems will be able to learn about the world so well and help the humans in lot more aspects. So currently, AI is being used in every place from movies to social media to finance to healthcare, every single industry. So the overall accuracy has gone high because with deep learning, the more data you keep feeding, the better it becomes with the right architectures. Then automated feature engineering, its algorithms can automatically extract all the important features which is needed to learn the data. See, even from the textual data, only important things are there, few important things, but a lot more information could be noise. So this deep learning based systems only focuses on what is important and tries to give less weightage to the things which are not important. Scalability. Deep learning can be models can be easily scaled, handle large complex data set and learn from the massive amount of data. We can do distributed training, distributed inference, lot of things in terms of scalability can be done to utilize these models. Flexibility, they can be applied to a wide range of tasks and can handle various types of data, including images, text, and the speech. And then it has a continuous learning option. So in the generative pre-trained transformer, this is an important word called as a pre-trained, which says this model is already trained with certain data. But now, if you want, you can also extend that model with the additional data. So that's called as a fine tuning. In the world of LLMs and even deep learning, this models, when we try to enhance them with the new data, we call it a the fine tuning of this model, where we enhance these models with whatever they have, we try to add some extra learning. So that is called as a transfer learning, fine tuning, continuous improvement. These are some different names for that. So now coming to talking about great learning. So great learning is like the leading edtech in providing education to professionals and higher education together. And they have a best in class completion rates and learner satisfaction overall. There are a lot of career transitions which great learning has helped to the overall audience. The whole course is structured around 12 months with a complete flexible structure. And also you have a peer-to-peer learning with the groups, which will enable you to learn together with the group with a complete instructor being there. top instructors are teaching this course, and also you'll have access to mentors who are also from the industry. On top of it, the overall faculty is people who are coming from best in class experience from industry, corporates, all together. So they are helping build the overall curriculum content. So you'll be learning from the best. On top of it, you will also get a curriculum which will have a foundations and also some self-paced courses. So you'll have a lot of learning. There's a lot of exposure to the domains within the overall AI field. You get to learn a lot of different tools because the tools plays a core role in AI-based systems. So learning about all the tools is going to be very important. So there are multiple tools which will be covered. So that's it for today. I hope the session was helpful to you, and I'll be happy to answer any questions that you guys have. So now time to for you, like ask any questions, and I'll be happy to answer. So guys, just go ahead with your question. So please fill the form which the team has shared. If you have any queries about the program, about the today's session, you can also fill your details over the form so that team can get back to you, reach you, and help you solve your queries. So, Anjan, you can fill the form and the team will get back to you for that, for getting the slides. Like any other questions you have with respect to the overall AI field or the job market or learning paths, you have anything, please shoot it over the chat and I'll be happy to answer. Okay, awesome, everyone. I think if there are no questions, we will stop it, but we will wait for 2 more minutes for you to share your questions. Okay, so Siddhartha is asking, so first of all, Rupesh is asking, can you please explain about the AI scope in upcoming future? So that's a very interesting question, Rajesh. So overall scope is, see, very wide. AI is going to be touching every single domain, every single application. It's not going to be any separate field. It's like every human is nowadays integrated with mobile. Mobile has become a part of our life. Like sitting, waking up, everywhere mobile is there. Same way, AI is going to be integrated in every single piece. So the future of AI is we cannot say it's like a separate field. It will all get integrated into every single field. So I would say AI is going to be there as a complete new component, which will stick from the start till the end. It's going to be like a computer. The way right now we are using computers to solve the problem, like computers are needed for us to work on any problem statement in a digital way. Same way, AI is going to be a helper for everyone. It's going to be a one more helper in terms of your personal helper or even AI based integrations in the applications. We are building AI integrated smart applications. So the future is very interesting. I think 2025 gave a good foundations to a lot of different systems with respect to agentic, RAG, LLMs. cloud code and all the systems, the 2026 is going to be even more interesting with respect to a lot of companies going to get it integrated in their systems. Over the 1 year, so much improvement has happened with respect to the systems. Okay, any opening, non any openings in deep learning in India? See, I think Siddharth, a lot of openings are there in the market because people are not just Gen AI, but even before to Gen AI, there are a lot of like Gen AI is not useful in every single problem statement. Gen AI, agentic AI, and all these things. There is a use case where it is more useful and it is not useful everywhere. Many companies keep struggling and try to integrate AI everywhere. It doesn't work out, and they say that okay, the AI agents are not working. But the thing is, there are use cases where this is more useful versus some use cases where it may not be useful at all. So, uh, deep learning is going to play a very important role where many companies are now moving toward building their own SLMs, hosting their own LLM models. So, implementing those LLM models, hosting them, and making it usable. So, all of those cases, deep learning is going to be very important thing. And even to understand the whole working of the systems. Now, many people just blindly start using LLM in building products without understanding the whole fundamental things in terms of how the systems work. But if you're able to understand how the system works, you can create wonders. You can build quick things on top of it. Okay. But if you don't know fundamentals, you will keep struggling in terms of using the system. That's what is happening in the industry right now. Everyone says we are Gen AI expert. I keep talking with many people, but when we actually talk to them, everyone just want to showcase Gen AI, but few people only know how the systems work internally. Okay, so deep learning is going to be the core of all of the systems in data. So I hope I was able to answer your question. Perfect. Thanks a lot. That's great to hear. Okay, everyone. So thanks for being here. I hope this was a good learning session for you all. So please share your feedbacks on that. Thank you very much. Have a great time. Uh, Good to have you all here. Have a happy weekend.